Hello and welcome to this LangChain tutorial. So in the previous video, we explored what are tools in LangChain and how to invoke the tools. But we left the part to integrate the tools with the LLM. And that is actually the real thing. When you let the LLM decide which tool to use, that's where tool calling come into picture in LangChain. So that is the topic for today. What is tool calling in LangChain? So these tools become extensions of the LLM's reasoning. You bind tools with the model so it can choose the appropriate tool call to get the result. So first thing is to understand how to integrate tools with the LLM. Right. So for integrating tools with the LLM in LangChain, you can use this bind underscore tools method. So with this bind underscore tools method, you can pass the list of tools to bind to the model. So for example, suppose if we take the same multiply tool we created in the previous video, then that's how you can bind it to the LLM. So first thing, LLM definition, so some chat model, you give model, and then what you do is you can call on that LLM instance this method bind underscore tools, and in that as a list you can pass the tools. So here it is a single tool only, but you can have a comma separated many multiple tools also. All right. So that is how you can bind the tools with the LLM. When you pass this list of tools to bind underscore tools like this, what you are doing actually is you are exposing their name, description, and input schema to this model. That allows the LLM to recognize when a user query matches a tool's purpose, it will respond with the structured tool call. So two things to keep in mind here. First thing is that you don't send the logic of the tool to the LLM. Only these three things: name, description, and input schema. All right. And if we take the example of our own multiply tool, then if user sends a query which requires multiplication, LLM identifies that there is already a tool, right? We have bound this tool here. So it will identify, okay, I have a tool which I can use to do this task of multiplication. And it will respond with a tool call, this is structured tool call, which is essentially a request to execute that tool. It will look like this, something like this, right? You have your own logic where you have functions which are annotated or decorated with @ tool. Then when you send a request which has some task, suppose this request will have a task that can be done by a tool here. So LLM will identify, okay, this task can be done by one of the tool which is already there and bound to this LLM also, right? Using bind underscore tool. So it will identify that and it will send a response with tool underscore calls with the information that this tool can be invoked with this argument. So that is what it will send, right? It will send a tool call which will look like this: name, multiply, argument are this. So invoke this tool with these argument. That's how it will be interpreted. So one thing to understand here is that LLM does not read or execute your code directly. When it recognizes that a user request matches a tool's purpose, it will send that tool call. So that makes sense also, right? That you don't give direct access to the code through LLM because your code may have some sensitive information, maybe some API key, some credentials. So that's how it works. You will get a tool call, then you have to run it. So that is also one thing which you should remember, that when it gives you a tool call, this LLM, that is just a signal that a tool should be run. But the execution itself is developer's responsibility because LLM does not read or execute your code directly. So it is up to you how you will run that tool. So how it happens is something like this. After receiving the tool call, these are the activities that needs to be done manually. So first thing is when you get the tool call, which will have this information, You have to first parse it to get the name of the tool and the argument. Then you can execute the tool with those argument. Then if needed, you can return the result back to the model so it can continue reasoning and produce a polished answer, because tool execution may be just a step in getting a final answer. So you may have multiple LLM calls also. Now this is one way to do it, right? If you want the orchestration to happen automatically, then you need to create an agent. So agent will handle the loop of detecting tool calls, running the tool, feeding result back into LLM and continuing the conversation seamlessly. So then it will start happening automatically. And that is what you'll actually do, right? Essentially, this tool calling is a step towards creating autonomous agents. When you create agents, what happens is workflow becomes kind of abstract as tool calls happen automatically. So it is better to first understand what happens under the hood by using manual bind underscore tools workflow, right? That will make you understand, or you will have a better idea of how actually this tool call happens. Then you can move on to full agent automation with the knowledge of what is happening behind the scenes, which will help you in understanding agents better, right? So I'll suggest you do it this way first, then you can do it using agents, because ultimately you will do it like that only using agents. You want to do this manual way, but this will definitely help you in understanding what exactly is the flow, how those agents actually work, because then it also this will happen, but it will happen under the hood or internally where you won't do manual job. Now let's try to create a example using the same multiply tool. Let's create a code to get a better idea how it actually works. So here only I'll create tools, say simple tool calling demo. So how you create this tool and all we have already discussed. So I'm just doing this much. I'm getting it. Then we'll do the other steps. So nothing much. This all anyway you'll do. We don't need this here. So we have tools. We have I'm using Chat Grok for this and to load the environment to get the key for Grok. Then we have this tool which has this name, these arguments, and this will be the description. So these three things will be sent to the LLM when we bind it. So how we bind it is using this method, right? Bind underscore tools. There will send this tool name. So now this will become LLM with tools, right? So this is the instance name I've given to it. Now once we have this bind tools done, multiplication is the tool, then we can invoke it using this one. So LLM with tools dot invoke. Here suppose I ask what is 3 times 7, right? And I'll get a response and we'll print that response. So let's first run it till here only. It is not yet complete, but seeing this response will give you an idea how tool call look like, what you get from LLM, right? So if we run it, python dot slash is an L11, within that simple tool calling. All right, so this is the response. Within that, if you see, we have content, and this is our tool call where we have all this information. So here if you see, So this is what we get, right? Tool calls in that, if you see, we have arguments: A is 3, B is 7, name is multiply, type is function. So that's what you mean by tool call, which is sent by the LLM. Now we have to do the job of parsing this tool call and actually getting the result. That has to be done manually, as I told you. So what we'll do now can be explained with this image. What we did is, what is 3 times 7? That is the query to LLM. LLM sees, okay, there is a tool which is bound to this LLM which can actually answer this query because it is multiplication. So it sends back a tool call which we just saw. Name is multiplication, arguments are 3 and 7. Now actually what we have to do is, as a developer, now it is up to you that you have to parse this to get this information, that what is the name of the tool, what are the arguments. Then you have to invoke that tool with the result. And right now we don't need to send it to LLM, we can just print that result. So that is what we have to do now. Okay, so we have already done the coding till here, where we have the tool and we have bound that tool to the LLM and we invoked it to get a response. So we already have a response. Now what we want to do is, we have to parse it to get the name of that tool which is sent by the LLM and invoke that tool. So that has to be done manually. So first thing we have to do is, first let's do a check if response has any tool call, these tool calls, right? There is a tool call or not. If response dot tool call, then only we need to do this. If it is there, then since it is a list, we can iterate that list tc in tool underscore calls. Then we can get the name of this tool. Okay, so when we get this list, if you see there, we have a dictionary with names. What we can do is, we can get the name. If tc name is actually multiply, right? That is how we can check if name of the tool is equal to multiply. Then what we can do is, we can invoke it. That's what we need to do. That means we need to invoke this tool, multiply dot invoke, with what that we'll get from here. So tc args, this will give me a result. So here actually, if you see, it will invoke this tool and return the result. That's what I have here now, which I can print. And that is how I can manually parse the tool call, invoke the tool, and get the result. So let's try to run it again. Tool underscore, okay, forgot response here. PC in response dot tool underscore calls. Sorry, forgot to save it. So result is 21. All right, so that is how you can do it manually. So this was a simple example with single tool. Now let's try to do with more than one tool. So what we can do is, we can create another one, multiple tool called. We'll try to do it with two ways. So I'm naming it demo1.py, and let me get all the imports and everything. All right, let me clear this part. This one is not needed here. So we have tool, we have all the other things. Now we have two tools, multiply and add. So name of two tools, argument for two tools, and description of two tools. Everything is there. So LLM will get these information when we actually bind it. So now we are binding two tools. So till here we have this ready. Now what we have to do is we have to parse the result, right? Same way what we have done with simple one, single simple one. So same way we'll have here. So multi-tool parsing will do here, which will get a query, and then we'll go through the whole process. So since it gets a query, I'll just show you how we'll call it later. Be something like this, right? So we have both here, multiply, then add 10 to the result. That will come as a query here. So once we get a query, first thing is we have to invoke, right? So that, let's call it first underscore response equal to LLM with tools dot invoke with this query, right? So first thing we'll invoke with this query. So it will get this query, please multiply 5 and 3, then add 10 to the result. So it will see, okay, we have some tools which can do both of these things. So it will send that information with the tool call that we can check here by printing this first response itself. That should have the tools. So first response, right? Now first call is done. Then we have to do the same thing. If this first response has tool calls, then we have to go through those tool calls for TC in this whole part. Let's take from here itself. All right, so we have to go through those tool calls. And if you want to check, you can also put a print here, tool calls, in this first response dot tool calls. Okay, so that will give you an idea how actually what we are getting in each step. So we have this, then we have to do the same thing, but now let's make it more generalized. So we'll get the tool underscore name equal to, how we can get is TC name, right? As I showed you in the previous one, this will be a dictionary, what you get as a tool call. From that I can get the tool name like this, and let's get the arguments also, TC args. Okay, now what we need to do is we have to execute each tool. So for that we have to do the same thing again. If tool underscore name is equal to multiply, right? If it is multiply, then we have to call the multiply dot invoke with the args, and we'll have multiple results. So let's do one more thing here. We'll create a list, result equal to, not result, results, let's keep it, because here also we'll get result. So this is this result. Otherwise, let's put it here, elif tool name equal to add, then you'll call the add.invoke.args, or add.invoke with arguments. Can have else also. Else we can just say result equal to, it is sending a tool call, but it's something else, then we can say tool underscore unknown. And whatever is the result, that we have to append in results dot append result. So we'll keep all the results because this time we will send it again to the LLM. So you will have better understanding once you see everything. So just keep doing. Now once we have that, again if you want to see what has happened till this step, we can just do tool results with these results. These are our results till now, what we have done. Now what we have to do is we have to invoke the LLM again. So with this for loop is over. Then what we can do is, this also actually should be here. Once this is done, then we can print everything. Now we have to invoke the LLM again, and now we can invoke this one, right? This LLM, because tool one is already done. We don't need with tool this one, because with that we have already run and got the information with tools. So now we can just invoke the simple one without any tool. So LLM dot invoke, and here what we have to do is we have to send these two information, results and this query. Let me get that prompt. So LLM dot invoke. The user asked a query. I'm telling the LLM user asked this query. Tool return this information. Please combine these into a natural language answer to give me a proper answer with all this information. All right, so that is our invocation. This will give me a answer again. So let's call it final underscore answer, and that is what we can return from here, final underscore answer. Okay, so if tool calls are there, then we do all this and we get the final answer. If there are no tool calls, then what we can do, else we can just return the first response, right? There are no tool call, then first response itself is the final answer. How we call it, we have already done that part. Then we can again print response. Not named anywhere response, or to be clear we can say it final response, and then within that actually we have to get the final answer would be response dot content. That will give me the final answer. So this is how we can do a multiple tool call. So let's try to run it. /11 tool call demo1. So here if you see, what we have is tool calls. First, if you see, it is saying name is multiplication. 5 and 3 are the arguments, as you can see here. Then it is saying you have another tool call also, which is add, which gets argument as 15, which is the product of these two, and b as 10. Add 10 to the result. So looks correct. And if you see, tool results will have 15 and 25, which is this one. So we have tool calls also, which we are getting here, then tool results, then we have final response, Final response, which is the whole response you get from LLM. So if you see the thinking process of an LLM, find the answer. First we multiply 5 and 3, which equals 15. Then we add 10 to this result, giving us 25. Therefore, the final answer is 25. That's how it has come to the answer. And that is your content also, which is final answer. So these are the steps, and that is how you can do multiple tool calling. So this is one way to do it. Now we'll try to do this same example again in the modern LangChain way, which will be more professional looking. Right now I did it with a simple one function just to make it clearer or simpler for beginners, so that you can easily understand what is happening. But now we'll try to do it with chain and runnable, which is the actual and professional way to do it. Okay, so we'll do this same example again, but with a different approach. Multiple tool calling demo 2.5. Let me first get the information. Okay, so this all is same what we have already done in the previous one with multiple tools. Multiply and add tool are bound to the LLM. Now we have a system prompt where we give all this information, that these are the tools available to you, and some guidelines whether this tool is needed or not. Output a structured tool call in JSON. If no tool is needed, answer directly. Don't try to um, execute or give a tool call when it is not needed. All right, so all that is given in this system prompt. Now with that, what we'll do is, first thing is we'll create a prompt, chat prompt template, where we can pass our system and user, right? Chat prompt template dot underscore messages is a list. I can pass first thing as system. System will have this information only, right? What we have already given. This system underscore prompt. Then we can have user, where let's say we'll pass some input. For now, that is a placeholder where we'll pass some input. So system underscore prompt and user, which will get some input. Now we have to define the same thing what we have done in the previous one. How will you parse the tool? So execute underscore tools, but this time it will be a little different in a way that once we are here, we already have output from one LLM call. That we'll see a little later why it is like that. When we chain it, that means we'll be here after our first LLM call, means output of that, which is a response only. So we do the same thing. There we were doing response dot to tool calls. Here we'll do output. If output dot tool underscore call is there, then we have to do the same thing. First thing, we iterate for TC in output dot tool calls. You can take that information, tool underscore name equal to TC name. args equal to tc args. Then we can go through our if elif kind of what we have done, right? If tool underscore name equal to multiply dot invoke with the args. And here again we have to append it, so we can take a results equal to some list, and that is what we append here. Let's do it directly. Results dot append is called. Tool name is add. Then what we do, add dot invoke, correct, with arguments. Now we have to funnel this result, whatever we get, to another link in the chain, right? So let's return it as a dictionary. What we get here is return. We'll have to return our results and what was the actual query. Both things we have to send. So let's say tool underscore results, your results, and query would be in output, not content. So content of this output will have the query, what was the original query. Then we can create another function, final underscore answer, which will get this data. And there what we can do is, let me get that part. So we'll invoke again the LLM as we did previously also in the previous example. So in data, there we were doing user asked query, tool return results. Here it will come from this data. So data query, tool return, data tool results. That's the only difference. Otherwise, it's the same. So this is our two functions now. Then we can create our chain. So chain equal to, first thing we'll have this prompt, right? This prompt that will be sent to LLM with tools. So prompt will go to LLM with tools. This will execute with this information. Then we'll call this function execute tools. For that, we have to wrap it within the runnable lambda execute tools. That is why it will get this information, whatever is the response of this LLM underscore with underscore tools. So it will have that information. Same way, we have to wrap in runnable lambda this final answer. Then we can invoke this chain with our same thing we can do. I mean, same query if we are sending. Here we named it input. That is why it has to be input. Please add 5 and 3, then multiply the result by 2. Now we have the answer. then we can use the same tool. Final response.content to get the final answer. So it is the same thing, but then done in a more professional, or you can say how you use LangChain modern approach with runnable lambda and chain. So we have, you can say, more modular, right? We have separate functions, and everything is funneled from one link in the chain to another on its own. You don't have to do at least that part manually now, what we were doing here, right? If you see, we have to make a call, first response, then we get that. Now we don't have that. With that, if we run this one, multi tool calling demo 2. Okay, there's some error. Human message. Okay, should put this also in quotes, double quotes. Okay, so tool return two values 8 and 16. 5 and 3, 8. Multiply the result by 2 is 16. That is our final answer. Final response, where does that start? Final response here. Content and tool calls. Okay, this time we have not printed. The tool calls will be same only. They have multiply and add with the respective arguments. So it's same thing as I have already stated, but done differently, just to give you idea about how you should actually do it with LangChain. So one more thing in tool calling is InjectedToolArg. So what we have seen till now is, if you see, right, all the examples, that all the arguments are sent by the LLM, right? Tool name, arguments, all you are getting through LLM. But that is not always required, because you may have some scenario where some of the arguments have to be get by the user itself, I mean developer itself. It may be some sensitive information, or you may pass something else, and then, so if you take a scenario, suppose a customer logins and then start some chat, so you have customer ID, but when you start talking, then you want to use the customer name. So you may go to database using that ID and get the name later, right? So LLM would not have the idea that how to get that customer name. So there are many scenarios, some sensitive information, or you just told that kind of scenario where all the arguments cannot be sent by the LLM. In that case, you have to specifically tell the LLM that these arguments are not to be sent by you, right? That's where injected tool arg is used to signal the LLM that this argument would be injected at runtime later. You don't need to send it. Why this is required is, if you don't do that, LLM may guess or hallucinate values, right? It will see, okay, I have to send that argument, and I don't see any value here. So it may generate some random value and send that. That is very much possible. So you have to make sure that you annotate some such arguments with injected tool arg in order to um, inform the LLM that these are the arguments which will be injected at runtime. So let's quickly see an example. I'll just get that example and show you. So first thing, let me create one injected tool demo.py. Okay, what I want to do is, so here is the example. All this is you've already seen. One new thing is injected tool.arg, which has to be sent as a metadata that this customer name is a injected tool.arg, right? So this is our function which acts as a tool, escalate to human. So that's where we generate the customer name and send that escalating what is the reason and for which customer. All right. We bind this tool query, you can say, or what you send to the LLM is the customer is very upset, escalate this. So this becomes the reason. Then it will send back the tool call that in this case, some human should get involved. So escalate to human, but it will just send the reason back as argument. It won't send the customer name because of this injected tool arg. So that is the idea here, that you have some query that will become your reason here in this function once you get back the tool call. Then the same thing, indentation is a bit wrong here. So here we have that runtime, we create a context that we inject a customer name. So here we are just hard coding it. In reality, it may, as I was telling, right, you may start some chat. I mean, customer may start some chat by login. So it may have some customer ID. Then you see, okay, customer is very upset. So then you go to the database to get a name based on the ID from a table and escalate to the human. So a human can start talking to the customer by greeting, right? Whatever is the requirement. So you need a customer name. That is the requirement for us. Then we are just unpacking those dictionaries in args and this runtime context and creating one single dictionary. That is why this double asterisk. And we invoke with these arguments. So now it will have both reason and customer name. Right? When we come to this function calling at this time, it will have both the arguments. And then we are sending another call once we have this information, right? See, it is returning this, returning reason, customer name. So using that, saying greet the customer using customer's name, get from context and inquire about the issue. So context is this result, which is this, what is written from here. So it, in the context, you have customer name. So LLM can get that name now and the reason. All right. So that is the flow of the example. The main thing here to understand is customer name has to be injected at runtime. If you don't do it, LLM will try to get value for both of these arguments, and that may result in some random name being selected by LLM and sent back as one of the argument. To avoid that, you have to do this. All right. With that, let's try to run it. L11 tools in that injected tool demo. Okay, still some indentation is not correct. This will actually be here and Is it giving for this or? Okay. Um, Give it as int. So if you see the response, right, it is greeting with the name and then it is giving some um, response. I'm so sorry to hear that you are upset. I'm here to help you resolve the issue as quickly as possible. Can you please tell me more about what's going on and how I can assist you today? And if you go to the tool calls, it has only reason as argument, right? Name is escalate to human. Reason is the only argument. It is not sending back the customer name. All right. So that is what you mean by injected tool arg, and that's all we have for the tool calling. Thanks for watching the video. Please don't forget to like and subscribe.